Hello and welcome back. Something a little bit different this time. I just want to show you the work I've been doing on my terrain generation tool. So this is a procedural terrain generation. The idea is I want to use it in my game for generating the maps that people will play on. I'm not very good at the artistic side, so anything that I can do procedurally is good for me. It's been quite a lot of work to get to where I am. I think there's still quite a bit of work to get it behaving exactly as I want it, but I've made some good progress, so I thought I'd show people what there is. I've got thoughts of possibly open sourcing the actual procedural terrain generation so people can modify it, add bits, hopefully let it grow as a tool. It's all written in C#, it's all using pretty much native Unity stuff, so Unity jobs, stuff like that for processing. So it's very easy to add or modify existing nodes. On top of that, uses a tool called Xnode, which is a brilliant open source tool for Unity for doing graph-based stuff. So let me show you how it works. Probably the best way to do this is try and create a terrain that I might want to use. So what I'm going to try and create is the iconic American West terrain with very flat plains with big mesas sticking up out of it, which are those basically hills with very vertical sides. So I thought I'd give it a go and see what happens. So normally the starting point for any terrain is some noise to give it its basic shape. We've got a lot of different noises. Got basic noise, which is purlin and simplex. Billow noise, which is very cloudy, wavy noises. Heterogeneous, multifractal, and the other multifractal are very good for creating ridge-type noises. Then we've got smooth gradient, which is just basically creating circular or linear gradients. And then Voronoi, apologies if that's pronounced wrong. I've never heard it pronounced, I've only ever read it. So that is basically for creating like cell-like noise, rock-like noise. So we'll start with something basic. We'll start with some purlin noise. If I run this now, you see nothing happens to the terrain because nothing's mapped to the terrain outputs, but you can see a little preview of the noise here. If you ever want to look at the noise a bit bigger, you can generate a preview node which can be attached to any node type, and that can be made as big as you want to see things a little bigger. So that's what our noise looks like. At the moment this is no good, and let's show you why. Let's connect this up to the heights. So this output heights modifies the Unity terrain that is linked to the graph via terrain details up here, and the terrain details just tells you everything you want to know about the terrain, including the prefab to use. If I click that, this generates this rolling noise, which is just a little dull and also has no defining features, so nothing to pick out as a messer. So what I want to do first of all is lower the octaves, and well, let's see what that gives us to start with. It gives us probably two distinct bits. So let's try upping this a little bit, seeing what we get here. So we're getting a couple of distinct heel lines here, but probably nothing. Let's just up this once more and let's see what we get on this. So we've got some continuous ridges forming, some nice low spots, but still let's go one higher. Let's see what we get. So this is too detailed now. We're getting too many rocky points. Maybe if we put that down to 1 octave, it might work a bit better. But let's lower this frequency again, see what we can get. So we've got some distinct high points, but probably again too many. So let's try just going down to this value here and seeing what we get. Sure. Okay, so we've got sort of continuous ridge here, continuous ridge here. Obviously it looks nothing like a messer, but the first thing we can do is add a curve to this. So if we take a modifier, we take a curve, we drop this in, put this in instead. We do so. This curve is a one-to-one mapping. So upon running that, nothing will change. So first thing we want to do is create those flat tops. So if we move this across here, click this, we start to get a bit further across. Start to get these flat tops forming, ridges where the height is cut off. So you can see the general shape we will have, which would look alright. But the next thing we need to do is get that shape in. So they have a very vertical. So this kind of have sediment build up where the softer rock has been worn down, and then they go to a vertical, much more vertical line. Let's give that a go. And there we go. So now we're getting the basic shape that we want. We've got this vertical part here. We've got the runoff of where the sediment would collect and run down, and we've got some nice flat areas which are good for gaming. So I think what we want to do is probably make that vertical bit a little bit larger on these. So now we just get, in fact, if we put that back, just come over there a bit with it. So we're getting a slightly less flat top there. We'll probably maybe narrow that even more. Let's bring this down, this across. Should give us, there we go. So I think this is quite an iconic look. You've got the flat area there, you've got a little ridge there where most things have worn away. You've got a few nice distinct hills that break up, or mesas that break up the terrain. At the moment it all looks very uniform. You've got very smooth curves which were needed to create the noise we wanted for these, but we haven't got anything really of interest on here. So the next thing we do is we want to try and make these slopes less uniform. So one thing we can do is we could apply some erosion. Now there's lots of different types of erosion we could apply. In this case what we'll apply is some thermal erosion. Let's have a look at what happens if we just push this in without any mask. So let's make this a bit more noticeable. If we click this, and what thermal erosion does is it models how rocks would fall. So if rocks are on very steep areas, they fall down, and they fall down until you hit a slope angle that is defined here. So the rocks will continue to fall over these iterations, and you just get this slightly lower angle of slope, which is no good for us because we don't want the vertical bits of the mesa eroding, because they are made from very hard rock, and the whole point of them is that they haven't eroded. So what we want to do is we only really want to apply this to the slopey bits just to give them a bit more irregularity. So what we can do for that is we can generate a mask. So if we go here, if we get a modifier, we can generate a mask based on the gradient. Put this output from this curve into here, and we can say we only want angles between 30 and 60 degrees as our gradient. If we have a look at these now, this has identified the angular bits of the curve. So if we put this back into here, just for now. So you've got the straight bits and the angular bits, and what this has identified are these angular bits here, and saying we can apply erosion to these. I think what I want to do is actually just decrease that vertical bit. So we've got this, and so what we can do now is we can use that mask as the mask in our thermal erosion. So now thermal erosion will only apply to the lower bits. So if we apply that now, we start to get some irregularity. Then we've probably got too much there. We're applying quite a high thermal rate just to kind of show it. So here we go, and now you can see we've got a bit of irregularity around the the edges. Not a huge amount, but probably enough. Maybe we decrease that and increase this. And yeah, you can just see instead of a nice straight line there, now we've got a curve here. And a good way to see this is to use another feature of this, which is a portal node. So if we put a generator, we generate a portal. A portal can basically output any node in the graph. So if we connect this to our output heights and we say we will output from thermal erosion, nothing will change. But we can quickly see what the thermal erosion has done by now outputting from the curve. So that was it with a straight curve, and that was it after thermal erosion. So we got a little bit of dip, just everything looks a bit nicer. So now what we can also have is, if you look at the message, you basically, in reality, these are created from hydraulic erosion, so from rainfall. So you get little dips and curves in them. So what we will do is we will add another modifier, and we will use a particle erosion. And this mimics raindrops falling on the terrain. And again, we don't want it falling on the top, because that's hard rock. So we only want to apply it to the gradient. So we take the output of thermal erosion, pass that into our particle erosion, and then change this to be particle erosion, so that's what's going to output heights. And we can have a look at what that does. You see here, it's probably a bit aggressive. The rain has fallen down, it's swept away this stuff until we have hit that. So what the minimum angle here is, we actually want 0, because we want now to apply it to anything lower. It won't affect thermal erosion because it's already below the height, but it means our particle erosion can nicely spread out and generate this like rain effect, where particles have fallen down the hill, they've gathered, they've moved sediment down the hill, and so we get these lovely effects here. So the other thing you'll notice on messes is, and for gameplay reasons, is you want to kind of probably be able to climb these things. So first up, what we want to do is we want to maybe try and get rid of this jagged stuff. So normally the best way to do that typically is increase the iterations and decrease the initial water, and you get a smoother if we go up to 50 with this, and we also rain for all that time. So always going to have an issue here where the gradient impacts the thing, but you can see the rain is having a much bigger effect, and we get probably too much going on now. Let's bring this back down and we'll just see what happens. And what we can do is we can actually make the erosion radius larger, so we get smoother bits of rainfall in there. But I think actually we wanted quite sharp rain across these ones. So let's do that. There we go. And then what we can do is we could probably do a reverse gradient. If we take a gradient and we say the minimum angle of this is 60, the maximum angle is 90, and we take our output from here into here as well, then we can generate a gradient that will just pick large bits. And then what we could do from that is we can use that as a mask for smoothing. So we could do a blur here. We can say only blur this area. We want this as our output. We'll keep that low to start with, and then we want this to represent the blur. We get a bit of smoothing going on there. And what we can do is we can grow this gradient slightly. If we put a grow modifier on here, we can just make this a little bit larger, and instead put that into the mask of the blur. There you go, and it just allows us to blur a bit of a wide area. We lose that lose that horrible jaggedness at the side, and we still get our rain effect going on the curves down there. In fact, if we up this just a little bit, we can keep the rain effect just a bit more. Just don't blur that out. There we get that. That's what we have. So that's kind of general shape, I think, of a terrain. It's not bad. We can have towns, villages down here. So what we want to do now is we probably want to make this a little more playable. So we'd want to be able to climb up these, even though in reality you probably couldn't. And to do that, we can add a terracing to it. So we know that the blur is the last point in our graph to create this general shape. So we've got that nicely done. And what we could do here is we could make this a subgraph, which would allow this graph to be used in another graph completely. You can have input nodes and output nodes on subgraphs. So if you had a subgraph that did a lot of erosion modifying, you liked the effect, you could then use that across multiple different graphs. Won't go into that here, but just to know that it does exist. So you could create an output for this, and this would say that this blur went into this output node of a subgraph. Then in another graph completely, you put a subgraph node in. I can't remember where it is. It's actually there, and you choose the graph that you wanted to use as your subgraph, and then it would automatically identify the inputs and outputs and allow you to wire in from your other graph into them. But we're not doing that for now. All we need is we've got our blur, and then what we want to do is we want to add some terracing. So if we take this, and we want to terrace everything at the moment, I think. So what we want to do is we take this now directly into our height. So we use our portal into this terrace. We say we have 20 terrace, steepness of 0.5, uniformity of 0.2, and we can see what that does to our graph. And we get this terracing going up here, so we can climb up here now and have a look. Still couldn't get up the rocks, which is fine, I think. Yeah, we can make these terraces more. We can put these at 40, and we can put the steepness slightly less, and that would allow it to blend more into the map, but still having things. So I think what we need is we need either more terrace or steeper. If we just increase our steepness a bit, give us slightly more. There we go. So we've got a terrace effect, still got the water effect. Those are probably shallow enough to climb up until you're near the top, and we've got quite a nice looking terrain. So the next step we would do is we can start texturing this. So textures, again, you can apply terrain splat maps. It should be fairly easy to write modify a node if you want to use something like microsplat, which is very popular terrain texturing library, shaders. For now we'll keep it simple. So we know that our final result is our terrace. That is our final node, and that gets output to height. So what we would do for now is we'll just move this over to one side, and we will create another portal, and we will say we've got terrace portal, and that goes into outputs. We could come over here. If we run that, everything will stay exactly the same because we are outputting the exact same details. Now what we want to do is we want to start applying some textures to our maps. And to do that, you basically generate masks of where you want the different textures, and then you apply those textures based on the mask. So the masks could be based on height, gradients, curves, all that stuff can be used. And let me show you texture node. So if you come to here, we've got textures, and basically you have nothing to start with. If we add a base layer, we can pick, say, sand texture, and then if we run that, suddenly all our terrain now has the sand texture applied to it, which already looks better, but isn't great. So what we want to do now is we probably want to identify these very vertical bits, which we've actually already identified with our gradient over here. All of these are renameable, so if we call this vertical gradient, we apply that, we got a vertical, we got that name now, is easier to keep track of. So what we want to do now is we want to add another layer into our texture, and for this layer we will choose some rocks, and what we want to do is we want to apply that texture where we've only got the vertical gradient. So we can either connect directly from that, but let's do a portal here because it's just easier to see. So we take our vertical gradient, and we drop that into our rocks, and we run that again. And you can see now anywhere that vertical gradient is applied, we are getting the rock texture. Quite interesting how that works. So what we probably want is actually to have a different gradient for these rocks, because we probably want to blend it in a little bit more. So what we can do is, well, let's select some height. So we've got a modifier, we can do a height selector, and this is normalized. So what we can do is we can take our terraced output, which is our final output, and into input here we could say we want a min height of 0.8, max height of 1. We want to fade that over 0. And we can see what that gives us down here. It's basically giving us the flat areas of our terrain blended slightly with the edges there. So instead, if we said, okay, we're going to use that for our rocks, we apply that, we get the rock effect now. The top of the mesa blended slightly into the edges because it fades across the edges. There we go. So we have that, and then we can add another texture. Let's add a let's add some rubble. And so for the rubble, we want to effectively apply the rubble to this terraced area, and we want to apply it blending, say 0.5 in. So we take that, and we know we've got this terrace already. No, we don't know we've got terrace. We know what we applied the terrace to. We didn't actually have a mask on the terrace, so what we need to do is we need to identify this area here. So let's do another gradient. So let's go and modify gradient. Let's put that into there, and this is probably a minimum angle of 10, maximum angle of 60. Let's see what that gives us for our gradient, shall we? So that gives us probably too much. Let's bring this down to 40. See what that gives us. Okay, let's just see what that looks like, shall we? So what we have, we can have a fade in and fade out on this of 10 degrees, just to give a bit of smoothness, and then we can drop that onto our rocks texture. There we go. So now any areas that are sloped gets the rocks texture blended into it. We get these nice sort of lines that you get, and again, because this has identified some flatter areas on the actual hills as well, it's blended it in. Obviously you could do a little more, we can make nicer textures. It's really just to show you how this works, but already we've got a terrain now that we've got nice looking areas. Right, so what can we do from there? Right, so that we're going to say that's our textures done. And what you can do is you can actually use where the textures has fallen as outputs for placing other things. So you could blend in different noise maps into here. You could output certain objects on where certain textures are applied, and you can also use any other mask for that as well. So let's start talking about objects and points. So this is the mask. This kind of shows you all the different masking bits. And masks are the 2D maps with effectively weighted values in each grid between 0 and 1, and then those masks can be applied to all sorts of modifier and other nodes. And then the second thing the graph can do is it can do objects. Okay, so we've generated our terrain, we've added some texture into it. Now what we need to do is add some objects and paths to make it more playable, basically. So the way paths and objects work in this tool is they are generated from points. Points are, as their name suggests, these little points within the terrain that you can then assign objects to, or you can link together with paths. You can modify those points, you can do some stuff to them, but let's start off by just scattering a load of points across the map. So what we do is we do these scatter points, and we will scatter 200 per kilometre. And what we need to do at the moment for points is always have a preview, because I need to preview them on the map basically because they're too small to see, but that is a work in progress. But if we run this, you can see down here we have 200 points generated across our map. Now I want these points to be trees, and I really only want them on the flat areas. So what we could do there is we can mask off any points, areas that we don't want. So what we could do is we could generate let's use our height tool, and let's say anything from, and these are normalized values, so anything from -10 to 10 meters, because our maximum height is 200. So if we run that, we get a map here, and when masking objects, anything of value 1 will have an object there, think of value 0 won't. Anything in between is a probability that if an object point appears there, it will be kept. So what we can now do is we can pass our points into a mask node. And we take that as our points, and we take this as our mask, and then we connect this as our preview so we can see it. And what this should do is it should get rid of any points that aren't on a flat area. So there we go. So now I actually want these to appear as trees. So now I say, right, I want to realize these points as trees. If we come into here, let's pick, we will have 2 trees types, I think. Let's pick that forest one there, and this dead forest, and let's say most of the trees are alive, some of them are dead, and we say each of these points will give us a tree. Let's run that, and we get trees appear on the map. Some dead, some alive, and we've got more alive ones than dead ones. Right. That obviously those points could become any type of object. We've got a prefab for us. It could be spawn points, it could be resources, anything really. It doesn't matter. The key is they're only realized as objects when you output those points as a particular type. So you could pick different sections of points on your map and output different objects for them, all that sort of stuff. The other thing points can do is that they can become, let's just tidy up these nodes a bit, is they could be linked together as paths. So for this one I'm going to have to use a test node, because my logic to figure out the best place to place landmarks is not yet finished. But if we do a place landmark, and at the moment this will just put a point on the map. So if we say we want the first point roughly here, so let's say that's 400 and 20, and we want the other point over here, which is probably about don't know, maybe about 800, 250, well, we can see. And then what we want to do is bring these points together. So we can merge points, can add them together, we can subtract one set of points from another, or we can unionize, so where we've only got a point in both, we keep them. But for now, all we're going to do is add these together. That will give us a list of points, and then into that we can pass that into a path object. So what a path does is it will take however many points it's been passed in. So that's the terrain map, and then these points here is input, and each point in the list will be connected to the next point. It does that via A* pathfinding. It will use the cost map, which we're not passing in at the moment, to figure out the best route to go based on cost. But let's see what this looks like now. And this should generate us a spline called path. You see there, and it's gone from A to B, and because there's no cost thing, every path is equal, so it's figured the best route for this path is up over the hill. We don't want that. We want to limit it to not be able to go over these high areas. So what we could do is we can create a cost map, and for pathfinding, a white area, cost of 1 is completely impassable. Cost of 0 is the easiest to pass, and anything in between has the relative cost. So what we want is almost a reverse of this map, or in fact exactly a reverse. To do that, we can use the curve tool, and we can say I want to do a reverse curve. So every value that was now 0 becomes 1, every value that was 1 becomes 0. If I pass this into here, I run that, you can see it's basically the reverse of that, and that is now good for our map there. So we pass that into there. If we run that again now, we have our path comes round the hill and into that area, which is perfect. Right, so what could we do with a path? Well, something simple we could do is we could generate a path mask from it. So what we could do is we could say, I want to, based on this spline, I want to create a mask. Each point in the spline 4 meters wide. I'm not going to have any fall off, just simplicity. If I run that, you get a mask generated on the map, and then I can say, okay, I can now use this mask, say for instance, to add a texture to the terrain where my path is. If I link him up to here like that, and I say, I'll just have it at 1 at the moment. If I run that now, I get a I'm not sure what's happened there with the texture. Just taking that off and just seeing if it fit. Let's take that one off as well. Right, so there's obviously a few little bugs, but let's add a layer back in. Let's take this one here. Let's select this mud here. Let's connect that up, and what we should see is we should see a texture for the path generated. There we go. So the bug there was that there was a texture in between the two that had nothing assigned to it, and for some reason it was then treating that as no texture, or fully splat matted with black. I'll look into that. But anyway, so there we have our path rendered onto the terrain. Now as you can see, we've got a tree in the middle of this path, and what we don't want is we don't really want trees spawning on the path. So at the moment we limit where the points we're going to select to be from this mask map here, and what we want to do is basically combine the path mask onto here, so this will also say don't spawn where the path is, and any maps can be joined together with the merge tool, and that takes like a base layer, which would be that, and then a layer on top, which is just another 2D or anything. So this could be noise, this could be heights, this could be just masks like this, it doesn't matter. And then you can choose how you want to mix them. So mix just combines the two proportionally, add adds them together, subtracts one from the other, max will take the max value of either min, and multiply will multiply the two values together. So multiply and add are the two most common. Multiply will always be a value of 1 or less, because obviously if you've got two values of 1 you get 1, otherwise you'll get less than 1, and add will typically bring the values above 1, so you need to renormalize them before you use them in heights, but there's a normalized node to do that. But for now what we want to do is we want to take this path mask off this mask, so we use subtract. If we run that, we can see the mask we've now got doesn't include the path, and so instead of putting this mask into the point mask as the mask, we could put this one in like that, and then when we run that, the tree disappears. At the moment there is a slight bug in that it is impacting the other trees that we've got from the random number. I need to look into that. That is a glitch. But anyway, so there we go. So now we've got no nodes. So the other thing we can do with paths is, let's get rid of this layer. We don't want this anymore. We can conform a mesh to the path. So say we want this to be a train track. So first of all, trains tend to be a bit smoother. So let's make this so there's less jaggedy curves basically. So we do that, make it smoother, and then we can say we can go up here and we can go conform mesh to path. So we could take our path in up here, and we can say I want a railroad to form this. If we run that, what we should get is railroad following this spline exactly, nice smooth curves, and because we've said stick to the terrain, the railroad will be on the terrain at each point. So you see we've got a little glitch there because we're obviously going up the side of a hill. So what we do there is we say, actually, before I do that, what I want to do is I want to conform my terrain to the path. So we take this and we take a path, and we take our terrain here, and we say I want it 4 wide. Again, let's not have a fall off curve just for now, and we then can say, instead of my final terrain up here being terrace, it can actually be down here, conform terrain to me. If we run that, what we should get is the terrain is nicely flattened where the railway goes. So the railway can still go up and down, but you get a nice bridge railway, and everything is nicely positioned for it. If we come over to this side, you see it comes all the way around through the hill and to the point. So there you go. That's just a brief overview, really, just to show you what I've been working on and how it's coming along. Like I said, main thing I'm working on at the moment is to create the logic so it can procedurally work out best place to put landmarks that you pick, and to do that, I'm basically doing a distance map, so each grid will know how far away it is from any given object, and then you can say, okay, I want to place a landmark of radius x, and it will find the best place to place it, saying, you know, I need to be 200 away from the other nearest landmark, etc., etc. Other things I'm working on, so I've got a river node, but it will generate basically a river that will flow to the edge of the map, but I haven't got any water logic or anything in yet to support that. And then, of course, there are a number of other nodes. Let's just go through, see if any. So flattener points will take a list of points and flatten the area around it. So if you're dropping resources on or buildings on, for instance, do that. Oh, another one you've got the ability to output output points along a path. So you could take any spline, and then you could say I want to place a point every 23 meters along the spline, and it will place the points to the sides of the spline depending on which offset you've picked. So that's very good for if you do a road network and you want to place buildings facing the road, or you want to play with resources along the road like in Rust. That's very easy to do using that. Once you've got the points, you can change them to objects. Something else is I haven't done biomes yet. I've got the logic written, but I haven't implemented it or incorporated it. So that will basically select different areas of the map as different biomes if you want, and then those biomes can be used in masks to say don't spawn here or spawn this type of object here, that sort of thing. Again, it's all done with masks, so once you've got a mask of a biome, you've got all the features you've currently got for those masks, so spawning objects in it, or paths and all that sort of stuff, or using it as a cost factor for a path, and you just get all that once you generated a mask. So basically masks and points. Subgraphs, I think I mentioned them earlier, but yeah, you could make any graph a subgraph and then use that graph in another graph. So if you've got a graph that does some neat stuff like, placing landmarks and creating your path, you could factor that off into its own graph, and then you could drop that into any graph that you're writing. Talked about the different noise types, the different points modifiers. Place on path duplicate will create a little cluster of points based on a little set of rules in there. Transform, so you can rotate points randomly, or scale them, so you can make all your trees or objects just appear more random. These outputs are trees. Climate, that's one kind of specialised for my game, but it just shows how easy it is to integrate a node into the game, and that will populate a grid with climates, so wherever the player is can query that grid, and it will tell me what the climate is in that grid, and that can be based on biomes. Again, it creates a little node, and you can pass masks in and say for this area here I want this climate to be this. Game map, that's for drawing a map. Again, you pass in masks, you choose what colour you want that mask drawn as, and it will draw a little it will draw your overall game map as a texture you can then use in your game. Obviously if you want to get fancy, you can write a node that will make it look hand drawn or stuff like that. It's all pretty trivial in terms of the node format. Obviously writing the logic to do that might be a bit trickier, but it's nicely self-contained. So textures you've seen, terrain types, that's another one specific to my game, and it just tells you the destination type of each point. So again, you pass in masks, so you might say this is rocky, this is sandy, the road is gravel, and then that allows it to, within the game, to play different sounds depending on the different paths you're on. So that's kind of like the logic of how it works. Like I said, I like to sort out grouping. I think someone might have done that in Xnode already as a fork. I'll need to look into that, because it'd be nice to be able to group this up and collapse it once you've built it, and then just use these portal nodes to lay out your graph better. But hopefully that's a good introduction, and like I said, I hope to make it open source if people are interested in expanding it or using it, and we'll see where it goes. Right, thank you very much.